Hello everyone, this video is brought to you by the Atılım University OpenCourseware project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and the video lectures are prepared by Ümit Alkuş. In this video, we will solve two problems about Chapter 9. Here, we have a collision problem. The object of mass m has an initial velocity. However, the mass of 2m is initially at rest. After the collision, mass m has the velocity in this direction with the magnitude of square root of 10 meters per second, and mass 2m has the velocity shown by v2 in this direction. For angle theta 1, tangent theta 1 is given by 2. However, we don't know theta 2 yet. In this problem, we are supposed to find the speed v2 and angle theta 2 in part A, and to determine whether the collision is elastic or not in part B. Conventionally, we first write the given quantity. m1 equals m, m2 equals 2m, initial velocity of mass m shown by v10 is 3 times square root of 2 meters per second, and the velocity of mass m after the collision denoted by v1 is square root of 10 meters per second, and tangent theta 1 is 2. In part A, we first note that tangent theta 1 is 2. In order to find the values of sin theta 1 and cosine theta 1, it is useful to draw a right triangle with perpendicular sides of length 2 and 1 such that tangent theta 1 is 2. Therefore, it is easy to show that sin theta 1 is 2 over square root of 5 and cosine theta 1 is 1 over square root of 5. We are going to use the momentum conservation. The momentum conservation in the x direction is m1 times v10, which is the initial momentum of mass m, plus 0, which is the initial momentum of mass 2m since v equals 0. And the final total momentum in the x direction is m1 times v1 times cosine theta 1, which is the final momentum of mass m, plus m2 times v2 times cosine theta 2, which is the final momentum of mass 2m in the x direction. Substitute the corresponding numerical values into this equation. We get m times 3 times square root of 2 equals m times square root of 10 times 1 over square root of 5 plus 2m times v2 times cosine theta 2. Here, m's are cancelled in both sides, and also square root of 10 over square root of 5 gives square root of 2. Finally, we obtain an equation with two unknowns, v2 and cosine theta 2, as 3 times square root of 2 equals square root of 2 plus 2 times v2 times cosine theta 2. And let's label this equation as 1. Now we can write the momentums in the y direction. Initially, in the y direction, the total momentum is 0, since there is no motion along the y-axis. Therefore, by the conservation of momentum in the y-axis, we have 0 equals m1 times v1 times sin theta 1, which is the final momentum of mass m in the y direction, minus m2 times v2 times sin theta 2, which is the final momentum of mass 2m in the y direction. Now, substitute the corresponding known values here to obtain 0 equals m times square root of 10 times 2 over square root of 5 minus 2m times v2 times sine theta 2. Again, m's are gone, and square root of 10 over square root of 5 gives square root of 2. Then we get 0 equals square root of 2 minus v2 times sine theta 2. Or we can find an expression for v2 in terms of theta 2 as v2 equals square root of 2 divided by sine theta 2. And let's label this equation as 2. Now we have two equations and two unknowns. Therefore, if we put this expression for v2 into equation 1, we obtain 3 times square root of 2 equals square root of 2 plus 2 times square root of 2 over sine theta 2 times cosine theta 2. Here, square root of 2's are cancelled, and it is convenient to write cosine theta 2 over sine theta 2 as cotangent theta 2. Finally, we obtain 3 equals 1 plus 2 times cotangent theta 2. Thus, cotangent theta 2 equals 1. Or equally, theta 2 is 45 degrees. Substituting this result into the equation 2, that is equation for v2, we obtain v2 equals square root of 2 over sine 45 degrees. And since it is equal to square root of 2 over 2, we write square root of 2 divided by square root of 2 over 2. Here, square root of 2's are cancelled, and you get 2 meters per second. Alright, this is the end of the discussion of part A. In this part, to show whether the collision is elastic or inelastic, we utilize the law of conservation of total energy. In this type of problems, it is sufficient to calculate the initial and final total kinetic energies. The initial total kinetic energy, denoted by Ki, where the subscript I stands for initial, it is equal to 1 over 2 times m1 times v10 squared, which is the initial kinetic energy of mass m, plus 0, which is the initial kinetic energy of mass 2m, since its initial velocity is 0. Now, we put the corresponding values into this equation to get 1 over 2 times m times 3 times square root of 2 squared, which is calculated to be 9m. Here, if you notice, we don't write the unit of the energy, since the result is not numerical. Next, we calculate the final total kinetic energy, which is 1 over 2 times m1 times v1 squared, which is the final kinetic energy of mass m, plus 1 over 2 times m2 times v2 squared, which is the final kinetic energy of mass 2m. Now, we put the corresponding values into this equation to get 1 over 2 times m times square root of 10 squared plus 1 over 2 times 2m times 2 squared. Therefore, the final kinetic energy is 9m. Therefore, initial kinetic energy is equal to final kinetic energy. As a final remark, we may claim that the collision is elastic, since the total mechanical energy is conserved. Okay, we have answered all the questions in this problem. Let's have a look at the second problem. Raindrops are slowed down by air friction so that when a drop of mass 5 milligrams reaches the ground, it has a speed of 2 meters per second. In part A, we will find the impulse given to the raindrop as it stops on the ground. In part B, we find the average force each raindrop applies to the ground, assuming that they are in contact with the ground for 10 milliseconds. First of all, we write the given quantities. Mass m equals 5 milligrams, where milligrams is not an SI unit, so it is converted into kilograms as 5 times 10 to the power minus 6 kilograms. The velocity of the drop when it reaches the ground is minus 2 j hat meters per second, where minus j hat is the unit vector in the negative y direction. The velocity of the raindrop as it is stopped on the ground is just 0, and the contact duration of each raindrop with the ground is 10 milliseconds, which is again in non-SI units. Therefore, it is converted to the SI unit for time as 0.01 seconds. In part A, the impulse given to the raindrop by the ground is found by J sub Rg, which means that impulse on R by G, where R is the abbreviation of raindrop and G is the abbreviation of ground, which is nothing but the change in the momentum of the raindrop. And this formula is called the impulse momentum theorem. Anyway, this equation becomes m times vector v2, which is the final momentum of the raindrop, minus m times vector v1, which is the initial momentum of the raindrop. Since v2 is 0, then we have 0 minus m times v1, which is equal to minus m times v1. Substitute the corresponding values into this equation as minus 5 times 10 to the power minus 6 kilograms times minus 2 j hat meters per second. And you finally get the impulse given to the raindrop by the ground as J sub Rg equals 1 times 10 to the power minus 5 j hat Newton times second. Well, let's solve part B. The average force on the ground by the raindrop is found from J sub Gr equals F sub Gr times delta T. In this case, the subscript means that the impulse on the ground by the raindrop and also average force on the ground by the raindrop. Or, since we are interested in force, we have F sub Gr equals J sub Gr over delta T. By means of the law of momentum conservation, it is very easy to show that the impulse given to the ground by the raindrop is equal to minus the impulse given to the raindrop by the ground. Therefore, we have minus J sub Rg over delta T. Substitute the corresponding numerical values to get minus 1 times 10 to the power minus 5 j hat Newton times seconds over 0.01 seconds. And finally, the average force on the ground by the raindrop is found as minus 1 times 10 to the power minus 3 j hat Newtons. Okay, this is the end of this video lecture, and see you in the next video.